That's path model, I want that one. Yep, I thought it was going the wrong way. So these, the value points to it. All right, for sociability, so my reverse coded items are 6, 7, 9, and 15. So I want to use 4, 11, and 16. So I'm going to do Q4, Q11, and Q16. I mean, I could do this with more, and we would get comparable results, but I don't want to work with a matrix. I want to keep my matrices relatively small so I can move them into SPSS relatively painlessly.
These are all independent factors. Well, we're assuming they're all independent variables.
Which ones?
All of them?
Technically, as a factor model, no, because we're assuming that they're being influenced by the latent variables. So technically, the latent variable would be the independent variable, the thing we can't see.
So everything we're putting in here is a dependent
Technically,
variable.
a dependent variable.
Okay.
Yeah. All right, so let me run this, fingers crossed. Okay. All right, spits out some results, and there we go. Now again, this is all good and fine, but what I really need is I kind of really need the standardized results. All right, so now I'm going to copy the standardized results from here. I'll put them into Excel. I got Q1, Q3, Q10, Q14. Let me get those values first. Okay, go to the next screen. So here's Q14. Now I've got Q4, 11, and 16. Let me get those values here. And then the other thing I need is the correlation between my factor scores. I'm going to put that one up here. And I'll explain why in just a second. All right, so let me do this. Now what I'm going to do now is draw the model. Can I do this relatively? I can do this relatively painlessly in PowerPoint. All right, so let me draw the model. Okay. All right, so my model looks like this. I've got 1, 2, 3 values here. That's the first, that's the sociability scale. Over here, I have this is my attentiveness scale, and this is the sociability scale. So let me actually let me draw the latent structures for each of those. All right, so we've got a latent variable here, and we've got a latent variable over here. Now again, so what we have now is, and this could take me a moment here. So we actually have this value is influencing. This is the part I despise about the new version of PowerPoint. And I won't remember the fact that I've actually clicked that shape. I've got to go back and click it again and again and again. Ugh. Okay. So this latent factor is influencing Q1, so let's see, Q1, Q3, Q10, Q14, and again, this was attentiveness. See if I can make all the fonts larger. Maybe a little too large. All right. This is the sociability scale. It is influencing the other variables. It is influencing Q4, I believe, Q11, and Q16. Now, the point here is that, so this is Q4, Q11, and Q16. Key now is I have a path for each of these. I have actually a parameter that gives the factor loadings for each of these. But I also have this piece of information. This one's the tricky one to draw. I need to draw an arc. And they always draw really weird. All right. Here, and let's stretch it out a bit. All right, there's my arc. And technically it's supposed to be a double-headed arrow. Format, shape. The line should have arrowheads at both ends. It's a curved arrow. Right? So if I want to calculate the correlation between Q1 and Q3, I would just take the values that I have. So the correlation from Q1 to Q3 would be, if I go back to my Stata output, correlation between Q1 and Q3 would be 0.8578 times 0.8435. That would be the correlation between these values here. So I'll put in 0.85, 0.8, I'll just type in 0.86 here to make my life a little easier. 0.86. So my correlation there is 0.86. The factor loading is 0.86, but that's interpreted as the correlation between my latent variable and Q1. Again, if I type in Q3, it's 0.84. I'll come and put that in here. This one's 0.84. And now I could also ask, well, what's the weight on Q4? Q4 is 0.85 or 0.86. So I'll type that one in over here. This is 0.86. So if I want to know the correlation between Q1 and Q4, well, I would use 0.86 times 0.86. But to get from here to here, I have to go back to AT&T. Sorry, back to ATT. Cross over this path, which means I need that correlation as well. That correlation value was 0.73. So I need the correlation here as well of 0.73. So to get the correlation between Q1 and Q4, it's not just 0.86 times 0.86, it's 0.86 times 0.73 times 0.86. Now I'm going to use that information in Excel so I can tell you that all of these are 1. The correlations with themselves are all 1. Let me get this so it's all showing up on one screen. Yeah, of course. Yeah, sure. Let me scoot up just a little bit. I'll. Yeah. All right. So now the first thing that I did. So the output I'm looking at here is SEM, standardized, not just SEM. Okay. So SEM, standardized. We'll give these, and then I took the Q1 0.857. Q4 0.85, and then at the very bottom you'll have the covariance 0.7335. Okay. So for everything on the first factor, it's still the same pattern of multiplying the values. Okay. All right, so these 4 variables are on factor 1. These 3 variables are on factor 2. This is the sociability factor. This is the attentiveness factor. Everything else is multiplied by the parameter for the first factor's loading, the correlation, and then the factor loading on the next value. And this then gives me the correlation values that are, quote unquote, off of each other. It is technically the covariance. I'm using the correlation matrix just to make the calculations a little easier. Yeah.
But when you pointed to 0.733, that's the covariance.
The standardized covariance.
Which is the same as correlation.
Correlation. Yeah.
Oh.
Yeah. Okay. Now, so what I've got here, so this is technically my sigma hat star. As in the star is because it's the correlation matrix. Well, this is all good, so what I should be able to do now is if I go back to Stata, I should be able to say, well, let's look at these values. Let me put this in. I want to actually look at the correlation between Q1, 3, 10, and 14, Q up through 14, 11, and 16. That should give me my correlation matrix for those values. Now, if I take this matrix and copy it into Excel, turn it into a table,